Testing. We good? Okay. Good morning, everybody. Everyone awake? Okay, let's try one more time. Everybody had coffee, right? Good morning, everyone. Awesome. So we're all super excited to be here today to do our workshop with you all for Effect Days 2025. Welcome, everybody, to the first day of our conference. I'm putting the Wi-Fi password up on the screen here for anybody who didn't see it on their table. And then also there is a GitHub repository associated with today's workshop. So you guys can feel free to clone it to your laptop, all the exercises and demos, also the slides for this presentation, basically all the code. Well, I'll try not to do that again. All the code that we're going to be going over today is in this repository, so make sure you've downloaded it. I think that Tim also dropped it in the Discord channel for today's workshop. Also, if anybody is not in the Discord channel for today's workshop, just like raise your hand and somebody will come around and help you get you into that channel, because you guys can use that channel throughout the day to ask questions and stuff like that if you don't feel comfortable raising your hand. Is anybody not in the Discord channel for the workshop? Okay, maybe we could have Mike and Mirella and people go around and try to help them get into the Discord channel. Mike, would you mind helping folks get into the channel for the workshop as well? Like if they're the Discord channel. Okay. Anybody else can give them a hand. Keep your hands raised if you're not in the channel. So our schedule today is pretty packed. We're going to try to get through everything, but we're also going to stay at a comfortable pace going through all of the material. I'm going to be with you guys for the morning session. So we've got our first session for an hour and a half. Then we have a quick 15-minute break. Second session right before lunch is another hour and a half, and then we break for an hour for lunch. And then Tim is going to pick up for the afternoon session with all of you guys for sessions 3 and 4. And then depending on whether we're running on time or whether we're running late, we'll also have some time in the evening for just general Q&A and networking.
For the people who are not in Discord, please message Mirella with your handle, and she's going to get you an invite to the channel.
Did everybody hear that? If anybody's not in the workshop channel in Discord, just message Mirella, and she'll get you into that channel. She'll add you manually. So in the morning with me, we're going to be focusing on learning kind of the basics. So the theme of the workshop today is really designing applications around Effect services. So basically service-oriented design with Effect. And we're going to go over from the very basics of how to build services with Effect, how to use layers, how to structure your application around these services, all the way to incremental adoption, using services, integrating Effect into backend services that are already existing that you might want to that you have an application you want to integrate with. And also, I think that we also have some examples in the afternoon that Tim will go over with some front-end integrations as well. So with me, we're going to be talking more about the basics, learning how to use services, learning how to use layers, going all the way from the beginning to more advanced concepts. And then Tim is going to take over and kind of go over more incremental adoption. Any questions about the schedule for today? Okay. And also, I think there are still some free seats at tables in the front. And so I know in the back, the folks that are sitting in chairs don't have a desk to put their laptops on. So I think there are still 1 or 2 free seats if anybody wanted to move. I think there's also outlets along the tables. Okay. So let's get right into it with section 1 of the workshop. So we're going to be talking about service-oriented application design in the first session of our workshop today. And our objectives are to really understand the concept of a service in Effect and what the purpose of service-oriented design in Effect is. We're going to gain some experience with building up services with Effect, and then composing them together, learning about how services can depend on one another, and how we can structure services together like that. We're going to explore the motivation behind the layer type in Effect, why it exists, what the purpose of layer is, why we can't just have services that we provide wherever we want. And we're also going to go over some best practices in structuring an application, and talk about some of the best practices that we have found work well as we've designed applications around Effect. Okay, so let's start with a quick introduction to services. So the purpose of a service in Effect is really to allow you to separate the usage of a particular group of functionality from its actual implementation. So kind of like this quote says, the goal is that you can code against an interface, not an actual concrete implementation of something. And programming against an interface means you don't have to worry about how the methods or variables or things that you're using are actually implemented behind the scenes. You can worry about the actual implementation later. And this has a couple of different benefits. It's very useful for prototyping. So you can kind of design the interface for services and start using them in your business logic without having to worry about how you're going to implement that later. It facilitates easier testing and being able to swap out different implementations as you're prototyping pieces of your application. And it facilitates composability and modularity in your code. So you can package up business logic into these nice, neat little pieces that you can then compose together, creating a very clear dependency graph of how different services in your application depend on one another. And it also allows refactoring pieces of your business logic to become much easier because, again, the implementation is abstracted into the service. So the external implementation, the interface is what you're using in pieces of your code. But if you refactor a piece of the internal logic, again, as long as you're meeting the external interface, you don't have to worry about that. One of the things that we're working on for the next major iteration of Effect is all the terminology around services. We know that there's kind of a lot of definitions and things that you need to learn in order to be able to work with services in Effect. So we are trying to improve upon this. But at the moment, we have a few pieces of terminology we at least need to have a basic understanding of before we can kind of get into exercises and examples and things like that. So we already talked about what a service is, right? It's just an interface that describes a set of operations or variables or things that we have access to. For example, a set of configuration values or a set of operations describing interacting with an external system. It's just like a interface that has some functionality associated with it. We also have tags in Effect. And a tag is, I define it here as a unique type level and runtime identifier for a service. And the reason for this is because a tag gives us a way to conceptually bind the interface or the service to an actual implementation when we're ready to do that, right? The tag is kind of the bridge between the interface on the type level and the actual concrete implementation that we're going to use in our application. And then we have context, which is the container type that Effect uses, which holds a mapping. It's basically on a conceptual level, you can think of it like a JavaScript map of tag to service. It's a little more complicated than that behind the scenes, but context is the data type that really backs the Effect requirements. So when you access a service in Effect or when you pull something out of the environment in Effect, you're really accessing something in a context object. So you're using a tag to get the service back, the implementation. So we're going to be going over a lot of code in our workshop today. Is this large enough for folks to see pretty much? Yeah, good. Okay, cool. Cool. When we define a service, it's very important that we at least have the basic understanding that we talked about on the slide before, because in order to define a service in effect, we need to create a tag and an actual, like the interface for our service. In practice, the lowest level strategy for creating services in effect uses something called the generic tag from the context module. And sorry about that, did not mean to hit space. Context.generic tag, though, in most scenarios is not what you're going to use. And this is because there are a few different problems with this approach. We only really recommend using, I'll talk about situations where the generic tag way of creating tags makes sense. But there are a couple of problems with this approach. I talked about how we need a unique type level identifier, as well as a unique runtime identifier for our services, so that we don't have collisions at either the type level or at the runtime level. And with generic tag, you actually have to make sure that your type is unique yourself. So you can see here, I've got my service identifier. We've got a error type that we're defining for our service, and we'll talk about tagged error in a moment. But we also have this cache interface that we're defining here, and you'll notice I've placed a unique symbol on this interface. And this makes sure that the type is unique, but again, this is kind of annoying. It's verbose. We've got the unique identifier we have to define manually, and then we have our service implementation for the cache, which just has a lookup method, takes a key, and will return either a string if it's successful in finding that key or a cache miss error. And then once we have all those pieces in place, we can use generic tag to define our tag, and then we have a unique, the string that goes inside generic tag is kind of the runtime identifier piece, right? So we have our type level identifier up above, and we have a runtime identifier as part of the tag. But again, this is kind of verbose. It's also annoying because you have to make sure that the service identifier on the type level is unique. So we don't recommend using generic tag in the majority of circumstances. The only time where it's really useful is when you are creating like dynamic tags for services. But again, most situations you won't be doing that. Instead, we recommend using the context.tag helper, which allows us to basically create a tag by extending the context.tag class, helper class. So everything gets packaged up into one neat, type. We've got a class cache, which extends context.tag. We still have our runtime identifier there, the string, the app/cache. But then we can actually use the name of our class as the type level piece, passing it in as the first generic parameter there. And then we can inline the implementation if we want, just to kind of make things even more concise. And then really quickly, for those of you unfamiliar with tagged errors and what they are in effect, we're creating a custom error type here for our cache type. And we're going to be carrying this through a lot of our examples. So I'm going to take the time to explain it now. But data.taggedError is basically just a really simple way of allowing us to create an error type in effect that also has a underscore tag property. And the underscore tag property is kind of a convention in effect that allows us to have a runtime discriminator, something that can allow us to differentiate between different errors in the error channel. So if we have like a cache miss error and, I don't know, user not found error in our error channel, that tag allows us to discriminate between those two errors or tell the difference between those two errors. And we also have operators in effect, for those of you who are not familiar, that operate specifically on the underscore tag property. So things like catch tag and I don't know, there are other ones. Anyway, now we're going to get into our first exercise where we're going to be creating the service definition. But before we actually open up our exercise and start working on this, I want to talk about, in my section of the workshop, what we're actually going to be doing. So for those of you who don't know, today is actually Father's Day in Italy. It's St. Joseph's Day. And I'm a big fan of dad jokes. For anybody who's seen my presentation from Effect Days last year, they're fantastic. And so the examples for our session this morning are all going to kind of carry the same theme throughout, where we're going to be building up a application that I've lovingly entitled the punishment protocol. The punishment protocol has a couple of different services, but basically the concept here is that the punishment protocol is a behavioral management system that weaponizes puns as a disciplinary tool for your children, or adults in our case, which we'll see in a moment. It basically takes the severity of a child misbehavior, matches it with a proportionally groan-inducing pun, and then, so basically for simple, like, misbehaviors, you might get like a, oh man, that's such a lame joke, even though it's not, it's fantastic. Or if you misbehave very severely, you might get a pun with many different punchlines, and it's very long and drawn out and excellent. We have a couple of key components to our system that we're going to be building up this morning. We've got the pun distribution network, which is a way that we can manage the limited communication channels that we have to actually deliver our puns. So things like dinner time, car rides during homework, basically optimizing the delivery channel for the best place that we can deliver that pun. We've also got the immunity token manager. So if a child is due to receive a pun for some misbehavior, but then does something really good, we can give them an immunity token that allows them to become immune from one or more puns. And then we've got Punster, the pun utility for neurologic sentiment testing and emotional response, which is a little API that I've put together that allows children, that fetches puns based on specific misbehavior categories and evaluates the result. So we get like a report back of how delivering that pun to our child went. So anyways, all of our examples are kind of going to be building up these different services, and then at the end, we'll be able to actually run our application and get some reports generated. One more thing before we launch into our first exercise. So this is kind of the dependency graph of our punishment protocol application. Our pun distribution network will depend on a punster client. So we're going to build the pun distribution network as a service. The pun distribution network needs to be able to use the punster client service in order to interface with the punster API. And then we are also going to have the immunity token manager, which depends on the punster client. So we've got this kind of dependency graph going on in our application. So I just wanted to show this in case folks were curious. So let's go ahead and open up in the repository that you all have access to in the exercises /section 1 section of the repository. You'll see a bunch of different files. There's the name of the exercise, and then there's one with -solution attached. We're going to be working in creating a service, and then when we're done, we'll take a look at the solution. We're going to be creating service definitions for all three of our services today. So the goal is not to implement these services or anything like that. The goal is to create a definition for our service. So taking the interfaces that you folks have been provided with and basically allowing us to use that interface in our applications. If anybody has, we're going to take like 10 minutes. If anybody has any questions or anything like that, please raise your hands, let us know. All right? There was a question about whether we're also going to look at effect.service because that was just added to the documentation like a week or two ago. Yes, we will take a look at effect.service. It's not going to be the focus, but I will say that for those of you who are interested in knowing more about the next major version of Effect, which we are working on, we're trying to make Effect.service more of the blessed way to create services in Effect. So we're looking to extend the functionality of Effect.service to kind of make it the default way of creating services. Okay. Does anybody need more time? Font size? Mike, is that okay? Can everybody see the code on the screen in the back from my editor? Good? Okay. All right, so let's regroup a little bit. There were a few things I left out when presenting you with this exercise, which we can just take a quick moment and go over. So there are going to be some shared pieces of code that you're going to see being imported in these exercises. It's really just so that while we're working on these exercises, you all can focus on the exercise and not have to worry about stuff that we don't need to implement. But if you're curious, you're more than welcome to check out what's in the different shared directories here. We can just quickly, I can't see this on my screen, so I'm just going to clear my head. We've got a couple of different things going on in here. The domain folder contains both our domain models and our domain errors. So you folks can look through those different things if you're curious. And then the services just contains some shared pieces of code that we'll import throughout the exercises. Again, just to make it a little bit easier so that we can focus on the goal of the exercise and not have to worry about implementing a bunch of code. And then, oops. We'll talk about what's going on in the fixtures directory when we get there. But anyways, so in this exercise, you were all presented with a bunch of different interfaces for the shapes. Whoa, sorry. The shapes that we want to give to our services. And when we say shape, we use that term a lot. In effect, the like service shape, it's analogous to the interface that we want to give to our services. So basically the functionality that we want our service to expose when accessed from, excuse me, the effect environment. So in this case, you were presented with a couple of different service shapes for the Punster client, for our immunity token manager, and for the pun distribution network. And your goal was to create a way to basically make these services usable in an effect program. Can anybody share like the way that they ended up making these services usable? What did you import and use? Yeah, context.tag, right? So we can take a look at my solution. Your solutions also may differ slightly from the ones that I implemented, and that's okay. There are many different ways to do things in effect. So if you guys open, excuse me, if you open the solution file, if you open the solution file, we can take a look at what I did to create these tags. But again, your solution may differ a little bit. Essentially, the first step when you're creating a service in effect, as we discussed a few slides ago, is that you need to create a unique type level and runtime identifier that we can then carry around in our programs. And in effect, we use tags to do that, right? So in my solution, I chose to use context.tag to do that. So for each one of the services, I'm sorry, for each one of the services that I wanted to expose, I went ahead and created a context.tag for that service. So I used the context.tag helper because, as I discussed, this is kind of the recommended way, one of the recommended ways. We'll talk about the other, effect.service, in a few slides, for creating tags. And then the first argument is what we call like the self type. It's basically just passing in the name that you gave to the class that extends the context.tag. And this is required in TypeScript for a couple of different reasons. I'm not going to get into like why this is required, but suffice to say, it's essentially to help us with typing on the static side of the class. And then the second type level argument to context.tag is the shape of the service or the interface of the service, so the functionality that you actually want to be accessible from that service. So here we've got our Punster client tag, which is using the Punster client shape that we defined above. So our Punster client is going to be able to create a pun by taking in some misbehavior that our child or adult did, and it will return to us either a pun or a couple of different types of errors. So if our children were immune, then we're actually, because they had a token from the immunity token manager, for example, we'll return a child immune error. If the pun was malformed, or if there was an issue fetching the pun from the Punster API, we'll get one of those errors back. And then we've also got another method here for evaluating our pun. So obviously, our puns are all fantastic, right? They're all great. But we still want to know how well our pun was received by our intended victim, I mean child. So we've got another method here for evaluating our pun, where we take in the pun, excuse me, the misbehavior, and the distribution channel, and we get back a report in a string format of how our pun delivery went. For our pun distribution network, we've got a get channel method, and that takes in a misbehavior and returns to us the most appropriate channel for delivery of the pun that we want to deliver. So, for example, we've got delivery channels like dinner time, homework, car ride, because in a car, totally like captive audience. It's fantastic. They can't get away. So you can potentially deliver multiple puns if you wanted to. And then we've got a deliver pun method, which takes in the pun that we want to deliver and the misbehavior in the channel and delivers the pun to our intended person. And then we've got our tag defined here. And you'll notice that in these tags, I've got that string that I'm passing in, right? That string needs to be unique across your application, because it's what we use as kind of a discriminator for the context itself to know which service to extract from the environment when you're working with Effect. So making sure that that string is unique is very good practice. And our convention, I'm not showing it here because it would have been kind of weird, but our convention for when we're designing Effect applications is to actually just make this the path in our package to whatever file we define that service in is. So for example, if this was in like source services pun distribution network, we might do like @myapp/ services / pun distribution network. We basically use the path to make sure that the identifier is unique. Does that make sense to everybody? Sure.
What would happen if you take the Punster client, for instance, and you name it as your class? What would happen?
Say that one more time.
The Punster client,
See.
the tag, it's not in the...
Yeah, this was a typo. That's my bad. Let's fix it actually while we're here.
But what would happen if it has the same name as the class?
Nothing. As long as it's a unique string level identifier, as long as there's no other Punster client identifiers in the context, then you're fine. So if you've got like a small app and you don't want to do the whole like path level thing, that's fine. In the Punster client that I designed for this workshop, I didn't use this. I literally just did the names of the services as their identifiers because it was a really small app. But for a lot of you folks, I'm assuming some of the apps you're designing are much larger. And so if you've got hundreds of services that you're managing, using the path is just a really easy way to make sure you don't end up with conflicting services. Sure. It's kind of like indeterminate behavior. The map can only hold one service for that identifier. So you kind of get indeterminate behavior. And maybe Mike can shed a little more light on some of the behavior that would happen if you have colliding identifiers for a context tag in your application. So for example, if you have two services with the same string ID, my answer was that you have indeterminate behavior because you may end up with one or the other service.
Yeah, basically the innermost will win, and you'll find yourself with a service of a type which is different from what's shown in the ID.
So the answer Mike gave, in case you all didn't hear it, was that the innermost service that's provided, and it's kind of hard to tell that sometimes if you're composing your services via layers. If you've got hundreds of layers, it may actually be difficult to tell. The innermost service will win, and you may end up with a service that you get back that's different from the type that you're expecting. So that's why the string ID here is very important to make sure it's unique. And that's why, again, if you use the path to the file you define the service in with the service name in that path, that's kind of our convention that we've used in a lot of the apps we've built. And I think the Discord bot even uses that. So if you guys want to look at that as an example. Does that answer your question? Cool.
Yes. Does this also include third-party libraries?
Does this also include third-party libraries? Do you mean if you're using third-party libraries that expose services? Yes. Yeah. Anything that is being, anything in your effect program, eventually is going to be resolved into that context object that I showed before, right? The effect environment is basically just a context object with, it's a little more complicated than that, but it's basically a context object. So when you've resolved that context object, either through layers or providing services or whatever's in that context is what you have in your environment. So if you're using third-party libraries that expose services, and you've got colliding IDs, it's kind of like what Mike said, the innermost service that has that ID will win. And so the behavior is indeterminate. So if you're designing libraries that expose services, it's very, very, very good practice to make sure that those IDs will be unique. So again, package name path service is kind of a good convention. Mike, anything to add?
We have evaluated, at some point in time, we've evaluated if to use kind of a new error behind the scenes and take the path of the file automatically. But it's also important that we have a type level identifier, because if you have two identical services in shape or one service which is a subtype of the other, and you have the same identifier, then you have the opposite problem. They might be different at runtime, but providing one will erase the type of the other. So in a single shot, in this case, we use the tag as a discriminator for both the type level and the runtime level. So yeah, that's the reason. It's the only hard limitation of structural type systems, unfortunately. The structure, we have to make it different.
Sure.
Would it be possible to use unique symbols, or are there some issues with it?
So I don't think that, do we support unique symbols? I don't think that we do.
We have been supporting unique symbols for a while, but what we found is that they make debugging more complex. Because whenever you get a runtime error, it's going to say symbol of blah, blah, and you have no idea what.
But if you've got the service ID in here, we can actually use that in the error messages. Like if we say, if a service that you access, sorry. This is very hard for me to stand in one spot when I'm talking because I usually like to run around. So Mike yelled at me this morning. I'm really going to try to stand right here. But the other thing, like Mike said, that we can do is if a service is not found, you access a service and that service is not found. If you've got a string ID in here that's kind of logical, that like maybe points to the path and the package that it came from, that's displayed in the error to say like this service was not found. These are all great questions, by the way. Any other questions about tags? Sure. No, yeah. No, there are no bad questions. I'm gonna say that very loudly.
And it seems we are also going to be talking about like best practices, right?
Mhm.
It seems like we're doing the job twice in a way because we're defining shape and then we're constructing the service
Mhm.
within a class. Can't we derive the right direction from the class and the interface? What is just like a suggestion regarding?
No, that's a really good question. That's a really good question. So the class, in this case, the class we create for the tag, we can't, the shape of the class is not the same as the shape of the service. Because when we yield a tag to get the service back or map over like the tag to get the shape of the service back, it's not the shape of the class we're getting, it's the shape of the service itself. So you can attach static properties and helpers to this tag that have nothing to do with the service. So for example, we could have like a static get or undefined, oops, right? And so these methods have nothing to do with the service shape itself, because the class in this case is being used just as an identifier. It's not the actual implementation of the service. What we will talk about in a few slides is how we can decrease the verbosity of this even a little bit further, and get rid of the whole service shape thingy by using effect.service, which is a new helper that we introduced maybe a month or two ago, and just got into the documentation and everything like that. It's still experimental because in the next major version of Effect, we'd like to try to find a way to make it the default because we think it's a little bit, it's much less verbose and allows you to further package everything up into one thing. We'll talk about that a little later. But does that kind of make more sense?
Yeah.
A little bit? No problem. Again, no bad questions. Okay? Yeah. Hmm.
Maybe I use the same idea. What can I do to prevent that, like creating tags from tags or something like that?
That's a good question. If you have, so your question is basically if you have a third-party library that you're using that exports some services, and you have a conflicting service in your own application, what are some strategies that you could use to deal with the conflict on from the consumer side, from consuming that library, right? Tim, do you have any like good strategies for that? I actually haven't run into that particular issue. Do you have? Yeah. Most of the time in applications that we've designed internally, we do put like the package name, even in the third-party libs we release, like the AI packages, the SQL libraries, everything. Generally speaking, the tags have @effect/AI, @effect/SQL, whatever, the package name as well, which is another strategy you can use. But if you run into that error, I don't know if there are any good strategies. One could be creating a tag for the if that package exports a constructor for that service, you could just actually make the service yourself, right? Create a context tag and just use the constructor that they export to build that service later. Any other ideas that you have? So the question is basically, if you're consuming a third-party library,
Yeah.
there's a conflicting string ID tag coming from the third-party package, and you don't want to, that you have a conflict in your own app, but you don't want to change the tag in your own app for some reason,
Like a third-party effect library.
or any other library.
Maybe in a modular you add something that is there between multiple services and like a repository.
Mhm.
Different, the idea could be the same. They represent the same thing.
I see.
So like sharing the same tag between different implementations.
That's an example now. Never got it.
Yeah, no, I think the best practice and the easiest way to solve the problem of conflicting tags, identifiers. I don't want to keep mixing up tag and ID. For conflicting string IDs, the easiest thing to do is prefix it with your package name, put the path in there, put the name of the service in there. And the likelihood you run into a conflict is minimized in that case. For conflicting tag names, like the actual name of the class, are you talking about? Like this, in that case? Of the string ID, yeah. And then the other part of your question about the third-party library, if it were me and I had a conflict locally and with a third-party lib, it's just easier to adjust the string ID in your own app, in my mind, because the ID really doesn't matter. It just has to be unique. So if you adjust it on your own side, that's probably the easiest thing to do. Yeah. Sure. I guess that is an idea we could take back, right? I mean, we haven't had as many third-party libraries aside from our own coming out until recently, so it hasn't become like a super major problem yet. But it is something like to think about, I guess. That could be an interesting idea. One sec. Yeah. Yeah, that's actually a good point too. If you do see that issue come up in your own apps, open an issue or something like that, either with us or with the library itself, because it hasn't come up yet, but it would be that's an interesting solution and it's something to consider. I think that when it comes up, we'll address it, but for now, I think the blessed thing would be package path service. Yeah, Victor. So yeah, that kind of has the same problem as yes, we could generate it like a unique ID, but it kind of has the same thing about then like for debugging purposes, it's like UUID is not found. Like it's a little bit easier if you fail to find a service that you didn't provide or something like that, and we can actually tell you based on the string ID, like this is what we didn't find. Could do that too. Yeah, you could have like a UUID you put on the. You could do anything as long as the string is as long as that string is unique. Then we're golden. All great questions. Also interesting ideas. So I appreciate the discussion. Any other questions about this? Okay, let's keep going. So we will quickly scroll through. The last service in here is the immunity token manager. We've got methods to get the balance of tokens for each child, award tokens to a child, and to use tokens for a child. And then we've got our tag for our immunity token manager here. And for simplicity and not having massively long strings, we're just going to use app as a prefix. But again, if this were a production application, we would do a lot of the strategies we've mentioned already. Okay, let me. Sorry, navigating with the mouse is hard. Okay. Back to the slides. So let's do a quick. Now my mouse is not working. Okay. Quick recap. So we imported the context module from Effect. We used context.tag to create unique service IDs for our services. We talked a lot about that, so hopefully the concept is clear. If it's not clear, by the way, we have folks walking around. We've got Mike, Tim, Julio, Johanna, all the Effectful folks are here. So if something's not clear and you want to chat with somebody, just like raise your hand and somebody will come over and you can chat with them. Okay. This workshop is meant to be very interactive and much less of me just talking to you. Because I can be very verbose. So I could talk for a very long time if you wanted me to. Okay. So we talked about creating the definitions for our services, which is great. So now we have kind of the building block we need to actually be able to use services in our application. So actually using a service in our apps is pretty easy. Once we have that tag defined, accessing the service within the context of our effect program can be done in two different ways. One is because these tags actually implement the interface of effect behind the scenes, they're actually like effects themselves. We can just pipe them into different effect combinators or methods. So for example, in this case, we could just take, if we had a tag called service tag, we could take that tag and just pipe it into and then, right? And then we actually get the implementation of that service back. The alternative, which I think most of us internally prefer for accessing services, just because we think it's a little bit easier to read, is in an effect generator, is to just yield the tag. Because again, tags themselves are effects behind the scenes, so you can pipe them into effect methods, you can yield them just like you yield effects. And once you do that, you get the actual implementation of that service back. And what's important to notice here is all of this can be done before you've ever written a single line of implementation code. At this point, we have not written a single line of how any of our app works. We're prototyping at this point, right? And that's kind of the beauty of Effect's dependency injection model, is you can really prototype in your head before you start worrying about how things are actually going to be implemented. And all of this is type safe. So if we actually tried to run this program, right, if we bound this generator to a variable and tried to run it or whatever, the program won't compile. It'll tell us we're failing to provide certain services in the type error. Like, because most of the run methods expect the requirements of our effect to be never. So if there's stuff in the requirements of our effect, the program won't compile. And we can take a look at some of that a little bit later. Okay, so let's take a look. Keeping all of our slide examples are going to be in keeping with this kind of cache thing that we've created. All of our exercises are going to be our punishment protocol. Okay, so kind of like in parallel. So we've got our cache, we've got the service defined here. It's all great. We've got a unique ID, we've got our service interface, we've got our error types, and everything is fantastic. And now we actually want to use the cache. So again, just like we saw on the previous slide, we can, we're going to be using primarily generators, just because again, it's a little bit easier to read these things in a stepwise fashion, in my opinion. We're going to yield the cache tag, right? So we yield the tag, and then we actually get the implementation of cache back. So if we were to hover over cache, I didn't enable 2/ on these slides because it was messy, but when we actually would hover over cache in this case, we would actually get the implementation back, this lookup method. And all of these code samples, by the way, are also in your workshop repository in actual TypeScript files. So if you want to like inspect variables and like see the types of things, you can do that as well. I should have mentioned that earlier. I apologize. But once we've yielded the tag, we can actually use methods on our service, right? So in this case, we're looking up my key and then we're logging that to the console, logging the resulting value to the console. And the other thing that's important to notice here, so we've got our cache tag, we're yielding the cache to get the service back. We use the service now that we have access to it. What's important to note as a last point is that effect tracks that in the type that eventually we're going to need to provide a cache, some implementation of a cache to our program, right? So in that third type parameter, we now see that our program requires us to give it a cache. We have to provide an implementation at some point, right? So anytime we yield a tag of a service, that requirement will be added to the type of the effect. So you'll see I need to provide a cache and a database and a blah, 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 blah. And then we have our other two type parameters for all of those. I assume most of you are familiar with the type parameters of effect, but I'll quickly review them if you're not. The first parameter is the success parameter. So if our program works like we intended to, nothing will happen, it's void, we'll get something logged to the console. If it fails, we'll get a cache miss error, because if we look up something that doesn't exist in the cache miss error, and then we require a cache. Okay. So for our next exercise, you guys can crack open the using a service file. And we're going to now define the main effect. And we're going to use service interface, the interfaces we've defined for our services to actually implement the main program logic. And so let's just take a quick look at that together. Using a service. So we've got our main to-do list here. We've got the business logic that we want to implement. And then we have a hint and some bonus objectives. So your goal is to try to at least get some business logic working, right? Based on the parameters I've described here. And as our hint, we'll probably need to access these services somehow, right? We've seen how to do that. So in our main program, we probably need to access these services. We still won't be able to run our program yet, but the goal of this exercise is to show that you don't need an implementation of the service to start using it, to start prototyping. So go ahead and get started. If there are questions, if you guys need a hand, raise your hand. We'll be walking around, and we'll take maybe like 10 minutes, 15 minutes to do this. Okay. I think in the interest of time, we'll come back together if that's okay. Did you say something too? No? Yeah. So let's come back together and go over my solution. But again, yours might look different. That's totally fine. Okay. So really the goal of this exercise was not for anybody to have like this beautiful working implementation of our code. The goal of this exercise was to get some practice with, now that we have tags for our services, extracting the implementation of services from those tags, and using the operations on those services to do things. So in this case, we have grabbed our punster client, we've grabbed our pun distribution network, and then we have a static list of misbehaviors, which I probably should have mentioned, and I apologize, I did not. That is my bad. But we have this static list of misbehaviors, which we can take a look at in a second. And we are getting a channel for our misbehavior, a delivery channel. And then we're creating a pun for our misbehavior, delivering the pun to the requisite channel, logging out the report that we get back. And then we're catching a few of the tags that we have here. So if the child was immune, and we got that error back from, I think it's create pun that gives us that. Let's take a look. Yeah, we get a child immune error potentially. Oops, sorry. If a child was immune, then we just log a warning that this particular child was immune. We're using up an immunity token. And if we have a failed to fetch error, we log that out as well. I think those were both bonus objectives. And again, your implementation may look very different from mine, which is fine. This is just the implementation that I went with. But the important things to take away from this exercise are that we've managed to write out all the business logic for our main application without still without having defined the business logic for our services. So if we actually take a look at the main effect here now, in that third type parameter, you'll see that now we require a punster client and a pun distribution network service to be provided in order to actually run this program. So if we tried to run this program, we'd get a type error. And this is not the type error, hang on. We're missing a few services that we need to provide. My type error looks a little bit different than yours. I'm like a little bit like leaking details from some stuff tomorrow, sorry, Mattia. But the point here is that we have been able to prototype our whole app without really needing to worry about how this business logic is going to be implemented. So any questions? Yes.
I guess you could define the whole thing without handling errors.
Sure. Sure. Yeah. If you define the whole program without handling any errors, are you asking if the services will still be in the requirements? Or so I think if I understand the question, it's will you also get a type error if you fail to handle certain errors? You can make it do that. You have to define a helper yourself to do that. In 4.0, we're considering exporting basically like identity functions that allow you to do that from every module. But in your own code, you would have to define basically an identity where you pass in an effect that has an E, and then the return type is an effect that has never in the error channel. And that would give you a type error if you didn't handle any errors. Certainly, yeah, and that's totally possible. We just don't have any helpers that we export currently for that. Yes. Correct. Okay, so the question is, in my solution, there's an error that I'm not handling. I don't remember which one it is. Yeah, there's two. There's the malformed pun error and a no channel available error. So what effect does, and this kind of goes beyond the scope of services, but we can talk about it. What effect does in the case where errors are unhandled when you run your main application is it automatically elects those errors into defects. So if those errors occur in your program and they were totally unhandled, these expected errors, these ones that are part of our domain, right? We've defined them as part of our domain, that these are things we know can happen. They automatically get elected to what we call a defect in effect, or an unexpected error, something that happened that we weren't planning on. And you'll get a full like cause printed out of like what happened. So for example, if we fail with a no channel available error because the channel we wanted wasn't available, the program would terminate and we'd get like a like trace of kind of what went wrong. As long as you're like annotating your code with spans, you'll get like a trace of what went wrong. But the point is you'll get a defect for any errors that were unhandled. Does that make sense? Sure. Yeah. And I think that was the question that, I'm sorry, what was your name? Dev. I think that was the question that Dev had, which is, sorry, Zev. Zev? Okay, cool. I think that was the question Zev had where the question was, isn't TypeScript meant to help you catch these errors so that if you have expected errors, you don't like try to run your program without handling them? And yes, that's true. But in order to force that in effect, you would have to create like an identity function that takes in an effect with an actual E, a generic E, and returns an effect with never in the error, which will then, TypeScript will tell you, hey, you have errors you haven't handled. in the next major version of Effect, we're actually planning on exporting like helper methods to do that to help. Because there are very valid circumstances where you want to run a program like this with expected errors that you're not handling. Because again, if you're prototyping, it's kind of annoying that like we would force you to handle every single expected error if you're running, if you run a program like this. Yeah, I mean, and there are also the thing that you can't do is run this program without providing all the requirements it needs, right? If you try to run this program without providing the services, you can't do that. And if you do run this program, you'll get like a service not found error, like we were talking about before. Yeah.
Is that standard for like say that map or is something else?
So and then so the question was, I'm using in my solution the effect.end then method instead of effect.flatMap and effect.map. Yes, they're essentially equivalent. However, effect.end then has some like I'll call them like superpowers or helpers. Basically, you can it is many different methods squeezed into one. So somebody's going to have to help me with all the things you can pass with effect.and then, but you can pass it an effect, you can pass it a raw value, and then it'll function the same as map. You can pass it something that's not an effect, and then I think it gets wrapped in a sync call. Promise. You can pass a promise. So it's kind of like flat map on steroids, where you can pass a lot of different things. And we chose to use and then in my section of I don't know if Tim leaned on that in his section, but in my section, we chose to use and then just to like keep a level playing field. Yeah.
They're more in line instead of the as if you're programming.
Mhm.
Like in this case, it's like almost equivalent, but more in general, what is like the rule of thumb for dealing with errors more in line versus at the end of the program?
That's a good question. The question is, when you wanted, I chose to deal with errors in line here versus at the end of my program. What are like best practices or recommendations surrounding how to deal with errors in line versus at the end of your program? Do we have any like recommendations? I'm going to give kind of like a non-committal answer here, which is it depends. My favorite software engineering answer, it depends. But the reason why I chose to deal with the errors in line here is because I still want that loop to run for every misbehavior if these errors occur. So I still want to get through all my misbehaviors, even if I encounter an immune child or if my pun failed to fetch. It would be unfortunate if my pun failed to fetch because obviously that child needs to be punished. But that's kind of why I chose to do it in line here. Because if I didn't and I handled the errors at the edge of my program and I failed on my first pun that I tried to fetch, it would terminate the program. Yep. The question was, is that the reason why I'm piping off of create pun here? Because I want to not short circuit the evaluation of that effect. Basically, if I yielded and then tried to do all the other logic, effect.gen would short circuit if there was an error. Whereas piping off the end of create pun and yielding that entire effect allows me to handle those errors as part of that effect. You can think of that pipe and all the stuff that happens in it as one effect. We call them, sometimes you hear us call them like regions, effect regions, like a block of stuff that we've piped together, a pipeline or a workflow or whatever. That's one whole effect, and so we can handle errors happening in that part of our program. Any other questions? Yeah. There are no stupid questions. Mhm. Yeah, that's a very good question. The question was, the generator is since kind of like deprecated in the effect gen functions. You don't need it anymore, but it's still there. The question was, can we still use it? Should we still use it for the pipeability it gives? Or should we be using .pipe or importing pipe? My answer is don't use the adapter. It's going away in the next major. So if you are using it, it will break in the next major. But I think the situations where you use pipe directly versus .pipe is totally up to you. If pipe is available, like .pipe on the data type you're working with, I just find it easier. I also find it more legible in many cases. But if you're working with a data type where .pipe is not available, like if you're using the array module from Effect, for example, to work with like an array, we can't attach .pipe to the array prototype. That would kind of be unsafe. So in that case, you might import pipe. So that's kind of like another it depends situation. But I recommend not using the adapter if at all possible. Cool? Okay. We have about 5 minutes till our break, our first break, I think. What I would suggest we do is maybe take our break. Do we have 5 minutes? Or is it 10:45? Yeah, 10:30 was our first break. I'm going to suggest we take our break early now, and then we regroup. Is that okay? No, that's not okay. We're not going to do it. Can I keep going for like a little bit? You need 5 minutes. Okay, okay. So I can keep going until they're ready. Okay. We're going to delay our break. We're going to delay our break until such time as we can take our break. Okay. Any other questions about this? Yeah. Yeah, that's a good question. That's a very good question. The question was, why am I using a for loop instead of effect.forEach? I just didn't need to use effect.forEach here. I could have easily used effect.forEach, but when we're in a generator and I don't need to do things concurrently, sometimes I just use a for loop to keep things clean. Not that effect.forEach is not clean. Again, it was like just it's my prerogative. I can you can do. The only time a for each would be necessary is if you wanted to do all of this in concurrently. So in my case, I wanted to do these things. I wanted to punish each child sequentially. And maybe really quick, we'll do your question, and then I want to show one thing. Yeah. Sure. So basically, I think the question was, you can correct me if I'm wrong. If we want to collect failed misbehaviors and then do something at the end of our program to deal with all of those failed misbehaviors, yeah. Again, we can kind of do whatever we want. We're in a generator, so we could create like an array, a set, whatever, maybe a map, I don't know, some data structure to hold our failed misbehaviors. And then we could, depending on whether we want to handle both defects and expected errors, like expected and unexpected errors, or expected errors, we could push the misbehaviors into that array of misbehaviors on exit, or on, we could catch all, and like basically we have the flexibility to do whatever we want. But what I would probably do to keep things like super easy is create an array at the top of my generator of failed misbehaviors or children I still need to punish, whatever, and push misbehaviors in there if they fail. And how I do that is kind of up to me. Like if I wanted to do it on any failure, I could tap error and like do it in there. If I wanted to do it on unexpected errors as well, like if something unexpected happened, I would need to handle defects in this program to prevent it from crashing. But I could do it in like a tap error cause before my catch tags. So it's kind of, you can do whatever you want, but the easiest way to do it in my mind would be to create an array, push into it when there's a failure, and then at the end of my generator, do something to handle all of those things. Does that make sense? The last thing I want to show in this sample here is our misbehaviors. You guys probably already took a peek at this, but let's take a look. Okay. So we've got a couple of naughty children here. So Michael has been extremely mean to me. The category of his misbehavior was he did not appreciate NeoVim. My beautiful NeoVim configuration was totally rejected and underappreciated. So that's the maximum severity punishment that we can give. The severity scores are on a scale from 1 to 5, and Michael he's getting a really gnarly pun. Then we've got Sebastian in here. And for those of you who don't know, Sebastian designed Effect's lovely cron module, but he spent way too much time on it, like way too much time. I think that our entire company retreat in November was spent on the cron module. Where's Sebastian? Is he even here? Not here to defend himself. Okay. But it's not that big of a deal, so we're giving it a severity of 2. And then we've also got Johannes in here for his gratuitous use of red arrows. That's kind of an inside joke, but also not that severe, so we're giving him a severity of 3. And then we've got a default set of tokens that we're awarding for good behavior. And so we've decided that Sebastian can be awarded an immunity token in certain circumstances because the cron module is actually kind of cool in effect. But anyways, when we actually run these programs later, or this program later, we'll see a full report of pun delivery for all of these naughty children. And we'll get to see like kind of what happens as we run the program. Should I keep going? Okay, I'll keep going. Oh, we're good?
Yeah.
Okay. Breaking on time. We'll resume around 10:40-ish. You guys can grab a snack and some coffee. All right. So we're going to get started again. So up until now, we've talked about how we can actually define a service, and we've talked about using services, but we haven't talked about how we can actually provide a service to our program, right? And we're going to start off with the most basic way of providing services, and then we'll kind of build up to maybe a little bit more of like the robust ways that you can go about providing services to your Effect programs. So the two of the most basic methods we can use to provide an implementation of a service to our Effect programs are Effect.Provide service, which allows you to provide a direct, like a concrete implementation of a service with its tag. So here you see we're taking some effect and using pipe to wrap it with provide service. We've got a concrete service tag for our service, and then we've got also a concrete service implementation. And the reason why both of these things are required, again, is because in the background, when we create the context object that Effect uses to manage all of your requirements, we need both the tag and the implementation. So hence, providing a service, we need both the tag and the implementation. It also allows providing a service to be type safe, so because the tag carries the service shape along with it. So we know that the shape of your service implementation is correct when you're actually passing it in. And then provide service effect is kind of the effectful version of that. So if your service needs to be actually constructed with effectful logic, like, I don't know, maybe you need access to a different service as part of building a service, or maybe you need to call out to an API to get some information, whatever. Provide service effect can allow you to pass an effect that returns a service implementation. Okay? So we'll take a look at an example of this. Going back to our cache example. So we still have the implementation of our program here where we're accessing our cache. We're using lookup to get some value from a cache key, and then we're logging out the result. In our program, you'll notice that we still have the requirement on cache here in the program itself. But to make our program runnable, we actually need to provide some implementation of cache, right? So in this case, we're using effect.provide service to passing our cache tag that we created up above. And we're providing a concrete implementation of the lookup method so that when we access the cache in our program, this is the implementation it's going to get back. So in this case, we're just succeeding with some string, but you can imagine that when you're building your services, you can implement them however you want. And in this case, I mentioned we're using provide service, but there is the effectful variant as well. If we need to build our service from some effectful logic. And now this program is actually runnable, meaning that the requirements channel of this effect, the requirements type, that third type parameter here is now that we've provided an implementation of cache, it erases cache from our requirements. So up above, you see cache sitting in the requirements there because we haven't provided one yet. But once we actually provide the cache to our program, it erases that type from the requirements. And now we can actually run the program. If we tried to run program up above with cache still in the requirements, we'd get a type error because we haven't provided an implementation. Does this make sense to folks? Yes? Cool. There are a few things to note about the provide service family of methods in effect, which are that they're not the most flexible way to build up the services you need in your program. We'll talk about a little more about why that is in a few slides. But it can be very difficult to get the order of provision right when you're providing many services. If you have hundreds of services that all depend on one another and maybe also all depend on like one service and like you have a big complex dependency graph, just using the provide methods can get complex. It's possible to avoid, I'm alluding to layers, of course, but it's possible to avoid using layers entirely to some degree. No, it is actually possible, but to do that with the provide methods would be kind of laborious. It'd be very difficult. So we're showing provide service as an example here because there are situations where this is useful. In particular, the provide family is useful when you want to provide implementations. You want to provide implementations locally to different parts of your program. So if you want to provide cache X over here, implementation of cache X over here, and another different implementation of cache over here in your program, the provides methods are kind of useful for that. And we'll show what I mean by that in a second. So let's take a look at a demo of what I mean by doing this. And I'm going to try something Tim suggested. I don't know if it's going to work. In the AV booth, let me know if this doesn't work. Did it work? You know what? Just making sure that they're not yelling at me from in there. Okay, this will make my life a lot easier. Hopefully, nobody in there. Okay, that's not great. Let's just do this for now. And then when Mike is back, we can try the other way. Okay. So we're going to take a look at a demo, which you guys also have access to all the demos. There's only 2 in my section, but we're going to first take a look at providing a service, like a single implementation to the entire application. And then we'll talk about, in the second demo, what I meant by you can provide different implementations to different parts of your program. So here, you can see we've got our cache. Go back over here. Okay. We've got our cache over here, service definition right here. We've got a static store that we've just defined as like a map to kind of show this example. And we've got an in-memory cache that we've defined, right? Because we've got a static cache, this is an in-memory cache. And maybe a quick note, all tags come with this .of method, which is essentially an identity function for the service implementation. It allows you to have a way to know to get a type-safe representation of the service without having to type it yourself. So for example, I don't have to do string here because cache.of knows like what the shape I have to pass in is. So you can just start implementing stuff and you get autocomplete and types. So the of method is just a helper on tags. And it knows key is a string because we've defined it in our service shape up above. So now that this is the definition of our cache, right? We've got the actual concrete implementation of an in-memory cache that we're going to work with. And we've got two sub-programs here, two programs that we're going to merge into a main program. Both programs access the cache by yielding the tag. Both programs look up different keys in the cache. And both programs log out the value. In our main program, we're just going to run both subprograms sequentially. And then to make the actual final program runnable, because if you'll notice right now, we still have cache in our requirements. To make the actual program runnable, we're going to provide this in-memory cache implementation of the cache service with the cache tag. And now we've satisfied all the requirements of our program. So now the program's requirements are never. We can actually run this thing. Oops. Hang on. And if you guys were to run this yourselves, which you can do in the README of our workshop repository, we instruct you folks how to use TSX to run these files. It's just pnpm tsx path2 file. If you run this, you'll see that the values you get out are in-memory value 1 and memory value 2, if I did this right. I may have forgotten to put the in-memory piece. No, yeah, here. Because we're basically accessing these values from the cache, okay? And this, again, what I'm trying to show here is that these two sub-programs or sub-effects or smaller effects are going to end up accessing the same implementation of the cache in the effect environment. But let's say that in one part of our program, maybe we want an in-memory cache, and maybe in another part of our program, we want to have a file system cache or something like that. Well, we can do that, and we can use provide service as one method of doing that. Right? So if we take a look at our second providing a service demo, we still have all the same setup code here, same in-memory cache, aside from the fact that we are same in-memory cache. And now we've also got an implementation of a file system cache here, right? So we've got the lookup method using try promise. It's using Node's file system module to read a particular file based on the cache key. And then we catch and map it to a cache miss error if we fail to read that particular file, right? So now, like, we've at least satisfied the interface of our cache where we need to have a cache miss error as the error type. Now, we still have our two subprograms, which again are identical to what we had before. But if we want to provide different implementations of a service, one of the methods of doing that is using provide service with different implementations to the specific programs. So in this case, instead of just yielding subprogram 1 to run it, we're also piping that into provide service and providing the in-memory cache to subprogram 1. In subprogram 2, instead, we're using the same tag, but we're using the file system cache. Now, some of you may be like, oh, hey, Max, you told me that if I have two implementations, the identifier, they're going to collide, blah, 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 right? That's not really the case here because you can think of these as two branches to our program, right? We've got subprogram 1 executing, subprogram 2 that's going to run. We're just saying that in subprogram 1, for the cache that you need, use this implementation. In subprogram 2, use this implementation. It's the same tag. We're just providing a different implementation of the service to different parts of our program. And you can mix and match this as much as you want. So for example, if I wanted to say everything in my program should use the file system except for subprogram 1, I could do that by taking this pipe and putting it here. And now subprogram 2 is going to get this version of the cache, and whereas subprogram 1 is going to get this version. So this kind of gets to the concept where I very, very briefly alluded to it earlier, but a lot of the methods in effect that you pipe together take in an effect and return a new one. That's kind of like the whole concept of building up a pipeline, right? You take in an effect, you pipe it into some method, it takes in that effect and it returns a brand new one. And this is exactly what we're doing here. Subprogram 1, we're piping that into provide service. It takes in subprogram 1, provides that implementation, the in-memory cache implementation to subprogram 1, and then returns a brand new effect that we evaluate with that new cache implementation. Whereas with subprogram 2, we're executing that in this entire generator, which is getting this version of the cache. So we're basically overriding the file system version of the cache with the in-memory one in subprogram 1. It's kind of like you can, if it's easier for you to conceptualize, like in this case, we're overriding an implementation. That's one way to think about it. Any questions about this? Yeah, you can think of it almost like in this. Oh, wow. Okay, stop highlighting stuff. In this top program, the context of the effect, if we conceptualize it, looks like this. Right? We have a cache tag that's mapped to an in-memory cache for this part of the program. But in the outer program here, this part of the program, we've got a context that's got the cache tag mapped to a file system cache. And the reason why this works is because we've overridden we basically have said, if I could like draw an X, I would. But basically we've said the file system cache, replace it with in-memory cache here. Does that make sense? So the question was, if I'm understanding correctly, I'll summarize. Basically, like this works because you're using the same tag but a different version of the service. Was that kind of like the question, or?
Context grab something out of it because it's already been there as soon as we satisfy it.
Yeah, so the question is basically like how does all of this, like how does providing the requirements work under the hood? And really what's happening is in subprogram 1, you could technically remove the fact that we're providing an in-memory cache here now because the file system is satisfying, the file system implementation we're providing to the entire generator satisfies the cache requirement for all pieces of our program, right? Subprogram 1, subprogram 2, they all get that version. But if we say in subprogram 1, we want to use an in-memory cache here because maybe we don't want to maybe it's a super hot path, we don't want to access the file system, I don't know. Doing this basically says we've already got a cache associated with the file system implementation. Take that file system implementation and remove it and put in a in-memory cache implementation. Does that make sense? So you basically get like a new map in the context that has like an in-memory cache implementation instead. Yeah. It's a good question. The question is, I'm going to summarize again. When you do this, when you override a service with provide service, does it also override any subdependencies that that service may be dependent on, right? So if, for example, we have, I don't know, some client that depends on a fetch implementation, the answer to that question is, with provide service here, you're taking like full control over what implementation you provide. So yes, it will override the implementation of that service, but not any dependencies that are anything else that's in the context. It's not going to touch. They're still going to be available. So for example, if you've also got in the context here, if you've also got like I don't know, a fetch service and a user repo service and whatever, those will still be there. It's just swapping, it's just providing this one service. It's basically saying, it's a, if I can even simplify this further. Whoop. Right. This is essentially all that's going on. I mean, conceptually, you're taking the key, which is the cache tag, and setting it to a new implementation. Does that track? Make sense? Hmm? I see. It would use the new implementation of the cache service, yeah. Depending on how the fetch service was built. Yeah. Yeah. Hmm? Yeah. Yeah, I got what you're saying. What if you want to make sure that the dependencies of your program are the ones that you expect in a particular service? Like you don't want things to be overridden. You don't want things to use different implementations, etc. We're going to talk about uh, more robust ways to provide dependencies to your programs when we get into layers in a little bit. So pause on that for a moment. Yeah. Mhm. No, it's basically the same thing. So if you of under the hood is literally an identity function that just has the type in there. So it basically it's just so you don't have to like retype everything, but you could assign that to a variable. It's just that sometimes when you're building your services, especially if they're effectful services, you're going to end up at the end of like a generator or a pipeline returning the shape of that service. And if TypeScript for some reason can't infer everything, you'd have to do like as XYZ, or you'd have to bind it to a variable with that type and then return that. Instead, if you use cache.of, it's a little bit, it's just more concise. It's like it's not a best practice or anything. It's literally just a helper. If you want to use it, that's fine. If you don't, that's also okay. Does that make sense? Cool. Any other questions? Cool. Okay, let's flip back to here. Okay, we're going to actually skip the providing a service exercise for a moment because it's quite simple, and I want to make sure we have time to get into some of the discussion. Based on some of the questions you folks were having, I want to get into some of the discussion on layers and things like that. I want to make sure we have time. And this exercise is extremely simple. The solution is, you can take a look at it. It's very simple. I just wanted to make sure you guys got hands-on practice with it. So we're going to skip over this exercise in the interest of making sure we get to talking about like motivating layers. Why do layers exist? How do we use them? Why are they great? Why do we basically never use provide service unless we have a concrete implementation of a service we want to just pass in for like a regional part of our program? So let's first start with motivating layers by talking about services that depend on other services. Okay, so if we look at the file system cache that we implemented before, this might be like slightly different than what we had in our example, but the gist is the same. This is not testable, right? Can anybody spot why? Right, yeah. The file system is hard-coded to the Node.js version of the file system. So we're depending on something that's specific to Node.js. So this is not easy to test without jumping through hoops with mocking or something like that. And this obviously won't work on runtimes like in the browser because we don't have Node's FS module on the browser. So how do we go about solving this particular type of problem? Well, when we have services that depend on other things that we can abstract into a service, well, this is the offending line, by the way, that we want to fix. When we have services with dependencies, we can just start building up a dependency graph, which then makes our application more testable. So let's talk about a little bit about why this is. When we break programs down into independent services, they can have dependencies on each other, but then if you go to test them or you want to swap out an implementation, all you have to do is swap out the implementation of that one service in your dependency graph, and all other services that depend on it will get that implementation. For example, in this case, we have a user service that depends on both a database and a logging service. And then the database also depends on a config service. And so we end up with this directed acyclic graph of services, right? And this kind of flows naturally from any application. Our applications are built in the concept of like, this piece of code depends on this piece of code, depends on this piece of code. We have a graph even in all of our apps. In effect, we think about those pieces of business logic as services. And when we provide those services to our program, the build order has to respect this dependency relationship. So config service would be constructed first in this case, because it's depended on by other services, right? So to build a database service, we need a config service. Then we can build the database service and the logging service. And then we can build user service, right? So you kind of go backwards through the graph to build it. We also talked about the dependency graph from our exercises, right? This is the same set of services we're working with in our exercises, much simpler dependency graph, but we still have a graph that we're building up. So talking about how to fix the problem from before, well, Jeremy gave the answer. Basically, abstract the file system into a service, because then it's fully injectable. Your cache, we can have a cache that depends on a file system, but we could also have another cache that doesn't depend on a file system, right? So maybe let's take a look at some code that shows how we can do this, and maybe then it'll make a little more sense. But also, like, raise your hand if you have questions. Yeah. You can't have circular dependencies in effect. If the config service depends on the logging, in that case, that would be possible, because logging service has no dependencies. If config service depends on the user service, that's an impossible relationship. Cycles aren't really possible in services, right? I gotta check, I gotta do a knowledge check sometimes. What happens? No, you literally, it would be impossible. Yeah, you could write, how would you write that program? Could you write that program?
Wait, but it will still be a socket at the top. See the service within us or the database service again.
Right. I think you'd end up with the cyclic dependency and types as well. But I'm pretty sure we could prove that it's impossible, but I don't want to do it on stage. Is that fair? I probably should have done that ahead of time, but yeah, cycles aren't possible. Because if you think about it again, just going back to the simple building block, that context, in order for, if user service depends on database service, which depends on config service, if config service depends on user service, the context doesn't have the dependencies to meet those things as you're building up the dependency graph. And even with the layer data type, which we'll talk about in a few minutes, it would be a relationship that's very difficult to model. Okay, so let's add the file system service into our program. So here we've separated out the requirement of a file system into a totally separate service, right? We've got a file read error that has a message, and then we've got our file system service that we're defining here. It's got a single method where we read a string from a file, okay? And it could potentially fail with the file read error. Obviously, it could fail with a lot of other things, but we're simplifying here. But there's still a problem here, and I want to see if anybody can spot it before I click the next button. Yeah. Fantastic. Yes. The file system is still leaked into the interface of our service, our cache service. So why, can anybody actually explain to me why that's a problem? I'll do it if nobody else wants to. Yeah. Fantastic. Yes. If you want to create a cache that doesn't use a file system, you still now need to, when you call lookup in your program, now that program requires a file system, even if you don't need one, right? Like imagine in the program from earlier, when we yield our cache, right? Now if we call lookup and we have a file system being leaked into our service dependencies, I'm sorry, our service interface, now that whole program requires a file system, even if that file system's never used. So in the vast majority of circumstances, you're going to want your services to have no requirements in their external implementation. So here, the fix is we remove the file system from our service interface, and we make our implementation agnostic of requirements, right? In the vast majority of circumstances, this is the correct thing to do. Sometimes you may have services where you want requirements in the implementation, but in the vast majority of circumstances, this is the best practice, right? Yes. Well, services can, so this is actually a good question. The question was, is it possible to have a context.tagged without requirements so that the methods don't have requirements? I guess, yes, it would be possible. But remember, yes, it's possible. But services can not only have methods, they can have like just static variables. They can have static effects. So lookup, if it wasn't a function, it could just be an effect. So services can expose anything on their interface. Is it at a type level? Yeah, sure, it's possible, though. If that's something that folks are interested in, definitely open a PR. But it's kind of like I said before, it's the best practice in like 95% of cases, but there are certain cases where you do want requirements because you're implementing functionality. For example, if you have a method that's scoped, that it's resourceful, it requires accessing a resource and then closing it later, or releasing that resource later, there'll be a scope in your requirements, which we'll also talk about in a second. But good question. Okay. So let's talk about how we can provide dependent services, and we're going to start with doing this with the provide service family of methods, and then we're going to kind of transition into not using that. So we've got our program here before with our service definitions. We've got the same program from before that requires a cache, and we've got our little stop sign that says this is not runnable yet because we have to satisfy a cache, right? We need to provide a cache to make this runnable. So the first thing we do is we can use effect to make a cache that relies on the file system, right? So we're using effect because we want to access the file system service as part of this, as part of creating this service. We want to get the file system so that we can then use it. And then we're actually implementing cache in terms of the file system service. So, oops, I thought I had a highlight. On line 36, we're yielding the file system. And then in the implementation of lookup, we're using the file system and mapping any errors to the expected error domain of the cache. But the key here is, this is kind of like working with closures in JavaScript, right? You can access variables in the closure, and then in the methods you expose from any returned object, you can modify variables in the closure. It's kind of the same thing here. We're yielding the file system in the quote unquote closure of the generator, and then we're returning the implementation of the cache from this generator. So now, instead of having when we actually look at the type of this effect, we'll see that we have the service implementation in our value. So we actually have the shape of cache now that we've implemented. But we have a requirement on file system now, right? So this is still not runnable yet, but we've abstracted the requirement of a file system out of the lookup method and into the constructors of services. So we're kind of taking steps towards like building layers and things like that. But right now, we're saying file system is a requirement to build a cache, not to use a cache. Does that make sense? Okay. So we're using provide service effect now. Remember I mentioned this was the other variant of the provide family. And when you use this, if the effect you provide has dependencies, has requirements in it, which we do, we have a file system, those requirements will get lifted into the return type of the effect you're creating, right? So even though we provide a cache, okay, fine, we erase the requirement of a cache from our program, right? It used to be void cache miss error cache, but now it's void cache miss error file system because yes, we provided a cache, but building that cache requires us to provide a file system. Is this tracking for folks? Yes? Okay. To finish off like making this program runnable, we need to provide an implementation of file system. And so we can do that, again, just using try promise. In this case, we're using the node file system. But again, remember, the file system in this case is pluggable. We can write whatever implementation we want when we actually provide the service. In this case, yes, we're using node's file system, but we could use, I don't know, bun, what's the version in the browser? Yeah, sure. So the point here is file system is now has been abstracted into a service, right? It's pluggable, and we're not hard coding a dependency on Node.js now. We can plug in bun or plug in node or whatever we want to actually make this program, to give the program the file system it needs. And what's great about this is it's all tracked on the type level. So like I like to say, even when we get into layers, If you just like follow the types, usually you'll end up on the correct path. Because you saw before, yeah, we wanted to make a cache that was dependent on a file system. That's great, we did that. But now the type is telling us we need a file system. Okay, fine, so we implement one, right? Sure.
Shouldn't primary error be in the type errors? Doesn't it propagate? Because there we have only cache miss error, but we
Yep,
catch.
typo. Sorry, folks.
It gets turned into a cache.
Yes, it does. Yes, it does. Okay, I was right. Okay. Because okay, let's go back. Here, we turn it into a cache miss error. And again, if this will not compile if you don't do this. If you just try to fs.read file string, the cache interface tells you it needs a cache, it will fail with a cache miss error. It can't fail with a file system error, right? So let the types guide you. If you spec out your service interfaces the way that you want them, then the types will help you. That's not even effect magic. That's just like the type system is going to help. I mean, it is kind of, I guess, effect magic on for the error channel, but. Okay, so we've provided a static implementation of our file system now. Now our program's runnable, so we can go ahead and run it. And the key here, again, is we have abstracted the file system into a service itself. But this is kind of like laborious, right? You need to keep track of everything that you're doing, the order that things are provided in, and especially, what if the number of services you have grows like in exponential form, which if you're building a large application, you could have hundreds of effect services. How are we going to deal with composing services in that case? How are we going to deal with services that we only want to build one time, right? Like imagine you have a service graph, we'll show an example in a second, where there's one service that should only be built once and shared amongst many different ones. It gets pretty complex to thread that in while you're providing requirements. And what about resource safety? What about services that require building scoped resources, things that you need to acquire and then safely release? For example, what if you're building a database service, like a Postgres database service, and you need to acquire a connection and then make sure that connection is released as part of the constructor for that service, not in the interface, but when you're actually building that service? What if you need to close the connection to that database when your program exits? It's kind of difficult. It's possible to do with the provide methods, but it's difficult. So this is somewhat legible. This is a very small example of what I was talking about, but building this graph with the provide methods is possible, but it gets really hairy very quickly. We've got two like subgraphs going on here that are related to one another. We've got the document repository that requires logging, database, and blob storage. Blob storage requires logging. The user repo requires logging, and the database. So to set up all these dependencies, and if the database requires, like I said, a scoped connection, then you need to close when your program exits. This all gets very complicated just using the provide methods. So the provide methods are best when you need to locally provide something, like a concrete implementation of a service. Usually it's best when you don't need to depend on too many other things, or you need to depend on things that are already provided as part of your program. Yeah. Is this tracked for folks so far? Cool. So the solution to all of the things I just mentioned is for us to start talking about layers. So we already mentioned that service might have more than one dependency. It might have 10, might have 20, 100. A service must have the dependencies that it requires provided in the correct order. We talked before about how cyclic relationships are not possible. Service might be resourceful. It might need to acquire some resources and then make sure it can cleanly release them as part of building that service, right? Because again, we made the distinction before when we were building our file system cache between the constructor for the service and then the actual implementation it provides. We'll get into that, a little more of that in a second. So that's why, in effect, we built layers. So I like to think of layers as constructors for services. They're a data type that represents building a service, right? Or one or more services technically, but usually you're only building one. A layer might depend on other layers or services. You might fail to build a service, right? In which case you want to produce some error value as part of building that service. So how do you represent that? We already talked about how you might need to acquire and release resources while you're constructing some service. Think about the database example, but there's plenty of others. Maybe you want to create a temp directory and then clean it up when your program exits. We want to make sure that these things are easily composable because we talked about the problem of we need to provide things in the correct order. We need to make sure that things that should only be built once are only built once. And going back to the building once point, we should try to memoize building these services as we go, because if we have a service that's expensive to build, like has to call out to multiple APIs to build that service or something, we don't want to do that multiple times. If there are many other services in our application that depend on that one service, we don't want to build that one service 100 times. We want to build it once and let all the other 100 services that are using that one just depend on that one built version. So the layer type allows us to very nicely describe all of these things and solve all of these different problems. In effect, the layer type is a powerful abstraction. It allows for representing service constructors as a value. And similar to the effect type, it has 3 type parameters. It has the requirements that it produces, or requirements out, right? This is the service you're building. Okay, you can think of it that way. So the database, the cache, the file system, whatever. That's the service or services you're building. It has an error channel, which is the possible errors that can happen while you're building that service. You can imagine like building a database. If you try to connect to the database and the network is down, that's an error that could happen while you're building that service, right? And then we have any required dependencies that creating that service requires. So if we think about it from the perspective of our file system cache, we would have a cache in the requirements out. I don't think we would have any errors. And then the requirements in would be our file system, right? Because we're producing a cache, but we require a file system. Is that tracking? If not, okay. And if we want to get like really technically, building a layer actually produces a context object with all the services that were in those the layers resolved into a single context object. And we'll talk about what I mean by this in a second. But the reason why I point this out is because we talked in the beginning about how the requirements of effect, when you run an effect program, all the requirements that program has, that you've provided to it, all of the services that it has, are stored in this like context thing, this context object where the tag is mapped to the implementation of the service. So when you take a layer that describes building all of these services and you actually build it, you end up with a context. There are many different ways of creating layers. And we also have many methods in the layer module. We're going to focus primarily on a layer.effect, but if you have a layer where you have a static constructor, there's layer.succeed, which just like effect.succeed takes a pure value for the service. And if you'll notice, all of the layer constructors take a tag, because like I said, the result of building a layer is that context object where tags are mapped to service implementations. So we need the tag. Yeah. When you build it. You can have an effect program can only have one context that it uses, but we're going to show how you can compose layers together. so that all of the weirdness before where we had to like provide the layer, then it required a file system, then we had to provide the file system, we can abstract all of that into like layers, which makes it much easier to reason about. I'm building X service. I need X services to build this service. And then when we actually go to provide it to our program, it will become clearer. And if it's not, let me know. So like I said, there are a couple of different constructors that are most common with layers. Layer.succeed and layer.sync are both for like synchronous type situations. Layer.succeed is if you have a pure value. Layer.sync is if you have a layer that you're constructing synchronously. Asynchronous layers would use either layer.effect, which allows you to provide a service tag and then an effect with that service shape, and layer.scoped, which is for services that need scoped access to resources. We talked about the case where a database needs to open a connection as part of building that service, and then when your program exits, it needs to close that connection cleanly. We're going to look at a quick example. Going back to our cache and file system situation from before, we still have our service definitions from earlier right here. We still have the same program from earlier that requires a cache. But instead, and we still have the same constructor for a cache, right? This is still the same make file system cache effect that accesses a file system and implements a cache, right? All of this is the same. But now we're going to use layer.effect to bind the cache tag to this make file system cache constructor. And what we end up with is a layer that creates us a cache and requires a file system. So in the layer type, we kind of have all the information we need. And it's kind of like what I said before. If you follow the types as you're working with layers, you're usually on the golden path, usually. So we still need a file system, right? So we can create a layer for the file system as well. And because we had a static implementation for the file system that was dependent on node, we can just create the static implementation here. And now we have a layer that produces a file system, doesn't make any errors, and doesn't have any requirements. Okay? So we've got two layers now. The layer module in effect has many different combinators that can be used to compose and manage errors. But the three most common ones are provide, which we're using here, which allows you to take the requirements that are produced by one layer and provide them to another. Layer.provide merge, which we'll talk about in a second. It's the same as provide, but you get both layers' services in the output. And then there's layer.merge, which just merges two layers together. So you get the same services, errors, and requirements. In this case, we've got the cache layer, which requires a file system, and we're providing the file system layer to it. Oftentimes, I find it's actually a little bit more intuitive to read this in a piped format, where you have cache layer.pipe layer.provide file system layer, where we're saying, hey, provide the cache layer this file system layer. And what we end up with now, once we've done this layer composition, once we've provided file system layer to cache layer, is we end up with a layer that gives us a cache and has no requirements. So all of the work we did before to provide service and like jumping through the hoops of like piping things together, making sure that things were done in the correct order, we've abstracted into the layers. And now all we have to do is use effect.provide, which allows us to take some program and provide a layer to it. And now our program is runnable. We don't have any requirements. Tracking for everybody? Provide is the method that will allow us to give a layer to an effect. Right? So let's quickly skip past this for a second. We'll come back to it. But I want to talk, because we've talked a little bit about scopes, I want to skip ahead for a second. We will talk about effect.service. in a second. But I want to talk quickly about, because I think this will come up, I think in Tim's section, there's going to be some stuff with scoped layers, maybe not. Can't remember. I want to talk about, I know we've been talking a lot, and I'm sorry. We will get to an exercise. But my last exercise of this section is the next one I want to do. So let's keep going. So resourceful layers, we talked a lot about scopes and what is a scope? Like the whole concept of a layer that we are building a service that requires some resources that we need to acquire and then release. It's like kind of like amorphous, and I think scope is probably one of the most misunderstood data types in Effect. And so to tackle that problem, let's take a tiny detour and talk about scopes, because they're actually like way simpler than folks make them out to be. A scope at its core is literally just a container for what we call finalizers, okay? It's a data type that has basically, I'll simplify, it has an array of finalizers in it. And you may say, okay, well, that's great. The heck is a finalizer? A finalizer is essentially a function that returns some effect that can be used to clean up resources. So when you create a scoped resource in Effect, when you do like an acquire release, for example, where you acquire some resource and then you want to release that resource later, the acquisition effect gets you said resource, but that release piece, that's called a finalizer. That finalizer will get added to a scope, okay? And then when all of the resources that are within this is going to sound really weird, within the scope of that scope, all of the finalizers get registered in order, right? So you end up with an array of finalizer 1, finalizer 2, finalizer 3. You can imagine that these register finalizer things are all effects that have some cleanup logic that needs to be executed. We register all those finalizers in order. And then when that scope gets closed via scope.close or other, we take those finalizers and we execute them in reverse so that all the resources can be cleaned up in the reverse order that they were acquired. And the reason why that's important is because imagine you have the database connection is a good example, right? Imagine you connect to a database, which is a resourceful operation. You bind the disconnect to the release part of that scope, which is register finalizer 1. And then we actually create a connection in that database, which we register finalizer 2 and we close that connection, right? This is like a weird example, but bear with me. We now have 2 finalizers. First, we connect to the database, then we actually create a connection, physical connection, I guess, I don't know. Probably the same thing, but whatever. The point here is, if we executed them in order, if we executed the finalizers in order, we'd first close the connection to the database, the like actual URL connection, instead of closing the database connection that we created after like binding to the database. Instead, if we execute finalizers in reverse order, we can make sure that resources are cleaned up. Any resources that are dependent on each other can be cleaned up appropriately, right? So the point I'm making here is that scope is literally just a container for finalizers, cleanup functions, things that need to be run in order to clean up, acquiring something that needs to be cleaned up. And so if we look at an example of this, when we perform a resourceful operation in Effect, it adds a scope to the requirements of our program, right? So in this case, we're using acquire release. We're not really doing anything that acquires a resource, but there's a scope that ends up in the requirements of our program. Scope is a special type. It goes in the requirements because it's very easy to track that way. If we do many of these resourceful operations, right, all of the finalizers, so the second thing in here, right, acquire release, the first thing is the acquisition, the second thing is the release, and that release effect is also known as a finalizer. So if we run that method multiple times, all of those finalizers will be added to that scope. That's in the requirements of our effect here. Tracking me so far? When we actually want to run the effect and close the scope, there are many different ways we can do this, but the easiest way, kind of the most semantic way, is using effect.scoped, which will create us a scope, give it to the program to run. Remember, a scope is a requirement, right? It's in the requirements channel. So effect.scope will create a scope, provide it to that effect, and then when that effect is done, it will close that scope. So in this case, we use effect.scoped to create a scope, provide it to the program, and when that program exits, close the scope. And you see that if we run that program, we acquire 1, 2, 3, and then release them in reverse order. Because if we look back at our program, acquiring 1, 2, 3, then the program exits, we release 3, 2, 1. Okay? It's literally a container for finalizers. We were going to go through an example of like manually building up a scope, but I think that it might be good to talk about this and then work on an exercise. So the last thing I want to talk about with layers before we start working on some exercises is what actually happens under the hood when you build a layer, because I think one of the most common put guns or like mistakes folks make with layers is calling effect.provide multiple times in sequence. Effect.provide layer 1, effect.provide layer 2, effect.provide layer 3. That's a mistake almost 100% of the time, because of this is what happens when you call effect.provide. When you build a layer, we're going to talk about what happens when you build a layer. When you build a layer, first you access the current scope and you create something called a memo map, which we don't really need to understand. It's the type and effect that we use under the hood to memoize services as they're created. Then we start traversing the layer graph. So all of the layers that you compose together that we showed before, where we like provided one layer to another and now we end up with a new one, we start traversing that graph. We check the memo map to see if that service is already built. And if it is built, we just keep going. We keep going through the graph because we don't need to rebuild that service. But if it's not found, we construct that service. If it requires a scope, meaning it was constructed with layer.scoped, then we use the scope we built at the very beginning, or the scope we accessed at the very beginning to create that service, add the service to the map, and keep going. So it's one big giant loop traversing the dependency graph and trying to memoize services as they're built. And once we're done, we end up with a context object that I talked about earlier. When we build a layer, we end up with a context object. And the reason why effect.provide multiple times in sequence is almost always a mistake is because that scope is shared by all of the layers that are in this build, right? Which is generally what you want. You want the scope to be at the point of the layer build. But if you call effect.provide multiple times, you end up creating a scope every time, then providing it to the build, and then when the effect exits, closing that scope. So you end up with multiple different scopes in your program and going through this process multiple times instead of just building the layer once and letting the service resolution happen once. Does that make sense? Yeah. Actually, I think I have an example of like doing this manually.
Like inefficient or?
It's inefficient and yeah. So to Tim's point, when you're building a layer, so what effect.provide does under the hood is kind of similar to effect.scoped. Creates a scope and provides it to the layer build. So this is the layer build, which accesses the scope, and it also creates a memo map. And to Tim's point, we mentioned before how layers, once they've built the service that you want, that service is memoized, and then any other stuff in that layer graph that needs that service just gets the memoized one, right? The memo map is how we do that. So if you effect.provide many different times, you're not memoizing your services. So you end up building them many times over. So imagine you have like, a service a config service or something like that, or something that's expensive to build. If you effect.provide many layers that depend on that service, you don't end up benefiting from the memoization. Yeah.
Like layer.provide.
Layer.
Layer.provide.
No, layer.provide is fine. It's effect.provide that does the work of creating a scope, building the whole layer, and then providing the context to the underlying program. I actually have like a quick example of doing this manually where we have some layer, right? We have a service, my service. We've got a layer for my service. And then I have an example of like doing this manually where we have a program that uses my service. So if we want to simulate effect.provide, we create a scope using the scope module from Effect. We use layer.build, which is the method under the hood that builds a layer and requires a scope. So when you build a layer, like I said, you get a context out and it requires a scope. We can take the scope and extend it to the layer builder, meaning we don't close the scope yet. We extend it to that effect. So now we've actually gotten our context out, right? So we have a context with my service in it that we can now provide, because effect.provide takes a context object as well. You can provide the context to your program, which is now runnable because you've provided all the dependencies it needs. And then we grab the exit value of the program and close the scope with it. So this is under the hood what happens with effect.provide. And the part I'm not showing here, because it happens within the build, within here, is the part where we create that memo map that memoizes your services. So generally speaking, in your code, layers should be provided at the very root of your application as much as possible. And you should only be effect.providing them like once. You should compose your layers outside and provide them once. Yeah. Yep. Yeah. Yeah. Yes, in certain cases, the order in which you provide layers to one another does matter. I don't like without getting too in the weeds. Anything that overrides like a default effect service, like logging or it's another example. Clock, anything like that. Anything that overrides a default effect service, the order does matter, because if you provide your override and then you provide other stuff, this is going to get hit first in the dependency resolution process, but all of these other ones are going to access the other clock, the default one. Like instead of your custom one, instead if you move that provide to the end, then everything above it gets the new clock. But generally speaking, it's more of an issue with default effect service, like trying to override default effect services with layers. That comes up. Cool. I don't remember what time this session ends, but I really wanted to see if you guys wanted to at least start working on the final exercise. 12:15. So there's an exercise that I have basically which allows you all to get some practice with merging, providing, and provide merging layers. Basically, it goes over like layer composition, where we talk about we have two layers. If we merge them, we merge all of the pieces of the layers. We merge the requirements out, the errors, and the requirements in. Providing layers takes the the output of one layer and provides it as a requirement to another. So in this case, layer 2 produces requirement, right? Layer 1 needs requirement. So if you provide layer 2 to layer 1, you erase requirement, and you end up with a layer that produces out 1 and requires in 2. So it's kind of like I don't know what the equivalent operation would be in more of a theoretical sense, but you end up erasing requirement here. But if you didn't want to erase requirement and wanted to move it into the output, there's provide merge, which does the same thing as provide, but moves the output of that second layer into the output of the resulting layer. So the exercise is basically for you all to get some practice with layer composition. There is essentially in the file, there is a list of layer types and a bunch of example layers. And the goal is for you all to somehow match the type of the layer using the default layers that are in there. So if we look at the example, this is Tim's, not mine. Exercises, session 1. So if we look at layer composition, you have all of these base layers, which are just types that we're declaring. And the goal is to try to achieve the target type using those 3 composition operators we talked about, which are the most common ones in effect. So if we want to take a few minutes, we can do that. And then right before we close this session, we can run our punishment protocol once together and just observe some of the output. I think that this is a good exercise because it gives a little bit of comfort to working with the composition operators. I know we didn't get to a lot of exercises I know we didn't get to a lot of exercises, but that's okay. I think that you guys have the workshop materials. You also have all our slides. Also, all the demo code, all of the code in the slides, everything is in the repository. And after today, I'll also figure out a way to merge in my Punster application into this repository so that you all have access to that API as well, the code that I wrote for that, which is not the best. So maybe we'll take 10 minutes, work on that, then we'll run our punishment protocol and we'll see where we're at. All right. I know that you all might not be 100% finished, but let's take a look at some of the solutions. And I want to reiterate once more that there are a lot of different ways to achieve these types. So if your solution looks different from mine, that does not mean it's wrong. But let's take a look at some of these. So in our first exercise, our goal was to create a layer that produces a config and a logging service, results in a config error or a log error, and has no requirements. In this case, we can literally just use provide merge to achieve this layer, right? We can logging produces logging and a log error in the error channel, and we can use provide merge to provide the requirement on config to logging while also merging their outputs. Does provide merge track for folks or not really? Yeah. Yes, merge works on both. Yeah, merge takes 2 layers and literally just smushes them together. You get this both layers requirements out, both layers errors, and both layers requirements in.
I might have forgot something that you might already have said. So you go again over the why, you use one or the other. So
my head is that sometimes probably you want just like create with the layer at the specific level of your program, but then sometimes you want to like have it at the edge.
Sure. Yeah. The question was, correct me if I'm wrong, when you would use layers to build your services versus provide service directly? Yeah. I think in the vast majority of circumstances, abstracting services into layers, the construction of a service into a layer, generally speaking, is the preferred method because of the composition utilities you get. And it also just allows you to be much more principled about where services are actually going to be put into your program. I think my default, and the other folks may disagree with me, I really only use provide service directly if there's a concrete implementation of a service that I want to provide. My usage of provide service effect is few and far between. Provide service is useful to me when I want to, like, when I have a static implementation of something and I want to locally override it in a part of my program, because it's not expensive to do, right? It's not like effect.provide where we have to go through traversing the layer graph and this and that and whatever. Provide service just map.set this tag to this implementation, right? It's much more efficient. It's much more, you don't have to deal with the memo map situation. That's kind of like my default. I near 95% of the time default to layers, like use layers to construct my services. And only a handful of times do I need to use provide service to like locally override something. Sometimes for like really small programs, like you can use provide service to thread dependencies through your program without passing them as function arguments also. So like if you have like a small little script you're hacking on and you don't want to pass something 12,000 times through like function calls, you can provide service, make a tag for it, provide service, and just pass it as a dependency instead. So there's like multiple answers to that question, but like most of the time I default to layers. And I think that's kind of like best practice. Okay, let's take a look at one or two more solutions, and then I think we should punish our children. The second example here was we needed a database. So here, the database layer, if we look at it, okay, requires a config object. So here we can, we don't need the config in the output here. So instead of using provide merge, we can just use provide, give the config to the database, and we get a database coming out, right? Does this make sense? Any questions about this one? Okay. For the third exercise, we want to produce a cache. To produce a cache, we need to have a database. So we can layer.provide the database, but then the database requires a config, so we can provide the config. And we end up with a layer that just produces a cache. But again, if, let's say, our requirements change, and now we want this layer, instead of just producing a cache, we also want the database in the output, and we can just switch this to provide merge, and now the database is in the output too. So it's provide and provide merge are almost the exact same thing. It's just about whether or not you want to propagate those requirements into the output or not. Okay. Let's skip past this one because it's kind of the same. Same thing with this one. Is there anywhere where I use merge? Yes. Okay. In exercise number 7, we want to create a metrics and a notification service. And we have a bunch of errors that we might need to handle at some point. So the metrics layer requires logging, and the notification layer also requires logging. Yeah. Sure. So you're saying because all of these other layers, some of them have requirements on config, like why does that work? Mm-hmm. Right. I see, I see, I see. Okay, so the question is about what happens in between these pipe calls here, and how is it possible that some of these other layers that require like config or database or whatever that are higher up in the pipeline are satisfied here, and now we end up with the correct type. Well, you can inspect what's going on in the pipeline type-wise if you want by doing something like this. Right? And you can see at each step like what types are erased. Okay? But what's really happening here is we're slowly erasing types. My point before when I was saying if you follow the types in your layers, you'll almost always be fine, still stands, and especially in this case, right? In the first step here, we are using our API layer, right? Which, whoops, requires auth and cache, right? So if we look at the first step in the pipe, we have our API being produced, we need auth and cache. If we look at the next one, we're now providing auth, great. But now we need a database config and cache, right? So if you keep going down the pipeline, okay, so we need cache, so we provide cache, that's great. What else do we need? Okay, now we only need database and config. So then we do one more step down, we were providing database to get rid of that requirement. Fine, and then we can keep going. And there are many ways to achieve the same type, just to be clear. Like you can do this in a variety of ways with the layer combinators, but that's what makes layers so great. There are two more points I want to make though before we run our program, because I think they're important, and we didn't really get to talk about them yet. At the very last exercise here, I made this one intentionally like somewhat complicated. And I also solved it in a specific way because I wanted to show something off. So, not show off, show something off. Be very clear. When you're working with layers, it is a best practice to, I'm gonna say this and then I'll see if there are confused looks on the faces. It is best practice to locally erase dependencies whenever you can. So if you declare a layer for service A in a file, if it's possible, you should locally provide the other layers you need in that file. And why do I say that? Well, this is an example of doing that, right? Here, we've got 3 layers we're building. Let's say we're in the database file. Our database layer requires a config. Great, we provide the config layer, and we end up with a layer that just produces database and config. And maybe actually it's better to start with the ones down here. We want a layer that produces API metrics and notifications, right? That's the final layer that our program needs in this case. API layer needs us to give it a cache and authentication. So in the API file where we define the API layer, we provide all of its dependencies that it needs in the form of this layer here. And now we have, when we export the API layer from the API file, we just have a layer that produces an API and does not have any dependencies. So this local provision of dependencies, why is it great? Because at the end in your program, when you want to make your main layer, the thing that you actually provide to your program, the final layer you want to give to your program, you can just merge all of your layers together and you're done. So locally erasing dependencies is really nice for like kind of dealing with the complexity of like the examples that are higher up, where we have to provide here and provide merge there and merge here and whatever. If you just locally erase dependencies as you go, it's generally a much cleaner solution. Does that track for folks? Do you guys understand? Cool. All right, let's run our program once and what did I do? Oh my God. Okay. All right, so just so we recall, let's quickly take one last look at our misbehaviors because we've got some extremely naughty children. Exercises, section 1. I know I'm not navigating in Vim like I'm supposed to. Don't judge me. Okay, so we've got some misbehaviors here, right? Michael, as we had mentioned before, dissed my NeoVim configuration, even though he asked for it. And so very severe punishment. Sebastian spent like way too much time on the cron module, but it is kind of cool, so not like super severe punishment. And Johannes has a gratuitous use of red arrows, so we need to punish him for that as well. That's an inside joke, but anyways, let's. You guys can all run this as well if you want, and you can modify the API key will be good till the end of the day, so feel free to use it as much as you like. Yes, this is correct. Let's run this. So I have an exercise command in the package JSON that just inserts the like TSX env file helper. So it just sources the environment from an environment file. If you guys want to use that, great. Otherwise, you can just run it directly with the required environment variables. Let's take a look at what's going on. So let's see. Michael, we delivered his pun during a homework session, and I'll scroll up while this is running. And we'll go over our report in a second. But let's see. Michael, we delivered a pun to Michael via channel type homework session. Maxwell spent hours perfecting the NeoVim configuration for Michael, but he didn't seem to appreciate it at all. It looks like Michael is taking configuration for granted. That one I don't get. Anyways, we send the pun for evaluation. It's got a grown potential of 75. I disagree. And then we end up with our pun delivery report. So our executive summary, the pun delivered during the homework session was moderately effective with a score of 63 out of 100 due to low receptivity and a coinciding cooldown period leading to a lackluster response from the child. Maxwell, intent on sharing his passion from NeoVim, attempted to lighten the mood. During an otherwise dull homework session, he leaned in to deliver the pun. The atmosphere was tense, with Michael frustrated by his assignments. The punchline, the setup about Maxwell's hard work lingered for a moment. When he finally hit the punchline, the response was tepid. Michael hardly registered the play on words, just like all of us. Anyways, the moment was fleeting, and although Maxwell chuckled and hoped for a better reception, it was lost on Michael amidst his concentration on the task at hand. We get a little metric analysis of the reaction intensity, the duration, some observations, and some recommendations. And maybe we can see if the puns for Sebastian and Johannes were any better. All right, so Sebastian, we got isolated very nicely in a car. Sebastian was so caught up in the tiny details of the cron module, I thought he might need a break. He really should learn to take a cronventional approach. Wow. All right. Let's see how we did here. We'll skip the narrative just for a second so we can see if Johannes got a good pun. Okay. We got Johannes during a dinner conversation. Johannes Schickling loves to use red arrows when asking for help. It's almost excessive. He really knows how to point out the obvious, doesn't he? That one was good. That was good. All right. Anyways, you guys can play around with this as much as you like. All the code is in the workshop repository. Thank you all very much for your attention. If there are any questions, so like I said, you have access to all the exercises, all the code, everything like that. I know we didn't get to everything today, but I kind of wasn't planning to. There's a lot of content in here. Hopefully you found this useful. At the end, we're going to ask for feedback, so please be really honest. We took a ton of feedback into consideration from last year into this year's workshop. So we hope you enjoyed the morning session. And if there are questions as you guys are working on the exercises by yourself, please feel free to ping me directly in Discord. Ask any questions you would like in the workshop channel, whatever. And we can chat about the different things that I didn't get to go over. But again, thank you very much for your attention today. I appreciate it.